NASA and space exploration over the decades. For decades, NASA has been launching telescopes into space, but the James Webb Space Telescope (JWST) stands out as the first to rival its predecessors in capabilities. Despite its hefty price tag and prolonged development timeline, the JWST has been anticipated as no other observatory before. Now operational, this larger and more powerful telescope is proving its worth by unveiling groundbreaking discoveries, including revelations about the enigmatic warp bubble, the expansive universe and humanity's curiosity. What exactly is a warp bubble and why is it significant? The universe, an expanse teeming with countless galaxies, black holes and exoplanets, sparks endless curiosity in humanity. Our species is inherently inquisitive, driven to explore and understand the cosmos. This curiosity often leads us to question whether intelligent alien life exists and if any extraterrestrial civilizations might share cognitive parallels with humanity. Challenges of space exploration. Exploring the universe, however, is fraught with challenges due to its vastness. While Mars seems relatively close within the solar system, Elon Musk's volunteers for colonization would still endure over 5 months in deep space's hazardous environment. Traveling to Proxima b, the nearest exoplanet, is even more daunting. Located 4.24 light-years, or approximately 25 trillion miles, from Earth, current technology makes this journey an unfeasible dream. Nevertheless, humanity's determination persists. Advanced telescopes enable us to explore distant cosmic phenomena without physically traveling to them. NASA's history of space telescopes, including the iconic Hubble, has paved the way for unprecedented insights into the universe's mysteries. JWST, a game-changer. The JWST represents a monumental leap forward. Positioned to replace the Hubble as the most powerful space observatory, it can look further back in time, exploring star formation processes from the universe's infancy. Being 100 times more powerful than the Hubble, the JWST provides insights into stars from over 13 billion years ago, thanks to the billions of years it takes light from these stars to reach Earth. Among the JWST's initial images are breathtaking views of the Carina Nebula, which contains massive stars within gas and dust clouds, and Stephan's Quintet, a cluster of galaxies engaging in a gravitational dance. The telescope also showcases the galaxy cluster SMACS 0723, where light from background galaxies is amplified by gravitational lensing, a unique phenomenon revealing faint, distant galaxies. Warp bubbles, defying limits. Perhaps the JWST's most intriguing discovery relates to the concept of warp bubbles. Unlike traditional travel, a warp bubble involves compressing space in front while expanding it behind, allowing faster-than-light movement without violating physics. This ingenious method avoids the time dilation issue associated with faster-than-light travel, where external time speeds up relative to the traveler. Warp bubbles, a long-time staple of science fiction, particularly in the Star Trek universe, have become a theoretical possibility that excites scientists. The torsion engine, central to the warp drive concept, reshapes space-time itself, offering a glimpse into an extraordinary future where interstellar travel becomes achievable. ###The promise of interstellar exploration. The idea of warp bubbles has shifted from fiction to a theoretical foundation for solving interstellar travel challenges. Reaching the nearest star, Proxima Centauri, 4.25 light-years away, would currently require thousands of years with our fastest probes. However, with technologies like warp drives, such journeys could be shortened drastically, transforming space exploration. The JWST and its remarkable findings reaffirm humanity's relentless pursuit of knowledge, pushing the boundaries of science and imagination alike. The cosmos, with its endless mysteries, continues to inspire and challenge us, promising a future of discovery and innovation. The Parker Solar Probe and warp bubbles. The Parker Solar Probe will be the fastest spacecraft ever built. Its speed is so extraordinary that it could travel from Los Angeles to New York City in just 20 seconds. Yet, even at this incredible velocity, it would take nearly 6,663 years to reach Proxima Centauri. However, using warp bubbles, it might be possible to reach Alpha Centauri in just 1 month, as measured by the spacecraft's onboard clock and Mission Control's master clock. Miguel Alcubierre, a physicist, proposed the concept of warp bubbles in 1994, shocking the global scientific community. Inspired by an episode of Star Trek, The Next Generation, Alcubierre, then working on his doctorate in Einstein's general theory of relativity, performed calculations on a scrap of paper and published his findings in a scientific journal that same year. The physics of warp bubbles. In his study, Alcubierre described a torsion bubble, where space and time are compressed in front of a spacecraft and stretched behind it, allowing rapid travel to distant destinations. However, his warp bubble concept faces challenges. Bending space with regular mass isn't enough to power a warp engine. It requires exotic matter with negative gravity. Alcubierre's warp drive would encase a spacecraft in a bubble of flat spacetime and twist spacetime around the bubble. To function, it would require either negative mass, a theoretical form of matter never observed, or a ring of negative energy density. Negative energy could theoretically be generated by creating an imbalance between particles and antiparticles, but this requires a vast amount of mass. Alcubierre estimated that a 100-meter warp bubble would need approximately \1 times 10^30 kilograms of matter, an astronomical amount, making the concept seemingly impractical for now. A new discovery in warp technology. Despite these hurdles, fans of the warp drive have new reasons for hope. In a serendipitous discovery, Dr. Harold White, a researcher at the Defense Advanced Research Projects Agency (DARPA) in Texas, reignited interest in warp bubbles. At the EagleWorks laboratory, White and his colleagues were conducting experiments on Casimir cavities, tiny structures used to study energy dispersion across wavelengths. During their numerical analysis of custom Casimir cavities, the team identified a nanoscale structure capable of generating negative vacuum energy density. This discovery hinted at the possibility of creating a real, manufacturable nanoscale warp bubble. Unlike previous analog models, this structure represented the first step toward a tangible warp bubble. Advancements in warp drive theory. White, familiar with Alcubierre's warp drive concept, refined the original design to address its reliance on theoretical materials and enormous energy requirements. His updated metric, known informally as the Alcubierre-White warp drive, drastically reduced the need for unconventional materials and energy. This revised concept has given both scientists and science fiction enthusiasts renewed hope for the development of a practical warp drive. White predicts that a small warp craft could be built and tested in the near future. However, he cautions that significant research remains necessary before a fully functional warp drive can be realized. The future of galactic travel. The idea of traveling across the galaxy at light speed within a warp bubble, reminiscent of Star Trek, continues to inspire scientists and dreamers alike. While much work lies ahead, humanity may one day achieve faster-than-light travel, unlocking the mysteries of the cosmos. If you're intrigued by the concept of warp bubbles, let us know your thoughts in the comments. Thank you for exploring this topic. If you enjoyed this discussion, please like and subscribe to our channel for more updates on space exploration. Join us on another journey through the cosmos by clicking the next video on your screen.